Hi everyone, this is where we stopped earlier. So what I did is I finished and I transformed all the values from text to numbers. Now this is what I will do one more thing. I will just create one variable real quick and then I will use the find and replace. So present, I'll replace it with 1 only for this column. So I will highlight this column. That way this applies only to this column. And then absent, I want it to be replaced with 0. Place all, so now I'm done. So what I will do here now, I will skip this and I will run the correlation. And then I will come back here, right? Because I need to delete this variable when I get into orange. Alright, so to do the correlation, I need to go to data and then I need to be able to see the data analysis here. So you might not see it in your Excel, so you will need to go to options and install the add-ins. So add-ins and then add-ins, go and make sure that data analysis or analysis tool pack is selected, then you will be able to see it. So now what I will do is I will go to correlation here and then where it says input range, I will select all the columns here. I will select all the data for me. Then make sure that label in first row. Say OK. Now it will create a correlation table for us. And as you can see here, the correlation, as we have learned in statistics courses, that correlation ranges from 0 to 1. 0 means there is no relationship or correlation between two variables, and the closer to 1, the higher the correlation is. So now as you can see here, for correlation between systolic blood pressure and blood pressure level is very high. It's 0.85, very close to 1. So that means it is there is high relationship or a strong relationship between those two variables. What we are really interested in here is we are interested in looking at the correlation between all the other variables and our target variable, or the variable that we want to predict or classify. So as you can see here, it seems to be age onset is highly correlated with the heart disease presence. And as you notice here, we have age range and age onset. Basically, those two variables are actually representing the same, or they are highly correlated. As you can see here, there is multicollinearity or high correlation between those two guys. And the reason is we are using this data set for illustration, kind of to see how we can transform data and how we can use variables for a data set, for prediction model and classification model. So now this is our correlation, so we are done with the correlation. So I will go back to my data set here, and I will make sure that I delete this variable because I'm not interested in it. I want to see here the text for my prediction, which is also supported in orange. So download. Now I will go back here and follow the steps here. So they want me to open orange. Alright, and then I'll open file, scroll down, or go and look for the file where I stored my variables in. So it is the heart disease file, and as you can see, I have all the variables here, and they are all numeric, except for my target variable. Alright, so now let's see what else they want me to do. So now I don't see I see only the variables, but I don't see the values. So in order to see the content of your variables, you can just create a data table. Now you can see all the variables that we have in our data set. Very good. So that's basically what we have to do here. Now I will skip this one because we already did it. Now we will go to create a link file to do some descriptive analytics. We have to explore our data set. So I can delete that one, and then instead I will go to visualize, and let's say distribution. You can just select this guy, and then I will see the distribution and of my variables. or I can also drag scatter diagram or scatter plot, and then as you can see here, the tobacco or the correlation scatter diagram for in tobacco intake in gram, and level of cholesterol is, there is correlation, and the correlation is 0.6 or 0.16. So as you can see, it is positive correlation. So this is just, I will let you explore with those descriptive analytics. Now we will move on. So let's delete this guy and remove this guy, and we will move on to the next step. So we have done this guy, and now a little more. So this is what I need. I need to assign my target variable. So I'll go back here, and then I need to assign this. So those are all features or predictors and or independent variables, and I want this variable, which is coronary heart disease, to be my target variable. So I will apply, and then we will move on to the next step. So now we will actually look at the ranking of the variables, because we have so many features. As you can see here, we have so many. In some cases we have 16 features or predictors. In some cases you might have tens or maybe 100 or hundreds of variables, but you don't want to use them all in your model, so you don't want to reduce it, to reduce those variables. So this is what we call it here, reduce the data or feature reduction process. So to do that, this is what we will need to do, is to go to data tab here, and we'll look for the rank widget. So I'll connect it to my data set, and I'm interested in the relief. So the relief basically ranks the variables that are more or highly correlated or more have higher predictive power for our target variable. So we have alcohol intake, age range, cholesterol level, age onset. So age range and age onset, we said they are the same thing, so we might get rid of age onset and replace it with tobacco intake level. Okay, so now what I will do is I will just keep this one here, that way I can see it, and then I will go here and make sure that I make all the variables that are not. So here, as you can see, I selected only the top 5 rank. So I'm going to limit my model only to the top 5 ranked features. So now the ones that are not included here, I will transform or make sure that the role of them is skipped, to skip them. So blood pressure is not here, and then systolic. So I will pause here and I will change all of them, and I will let you change yours accordingly, and I will show you my results in a little bit. Alright, so now I just finished actually skipping some of those variables that we are not planning to include in our model, and those are the variables that I ended up using. So the only ones that are as features are age range, tobacco intake level, alcohol intake level, cholesterol, and obesity. So you get the idea, and I will keep my target variable here as target. So even if your results are different when we did the relief, let's skip. That way we can compare. You can compare your results with mine. Just we will keep only those variables, even if you had better results or different results from mine. So we will keep those variables only for the sake of this illustration. Alright, so then we'll move on and see what is next. Alright, so we skipped all of those. Now we will move on to step number 5, 6, and 7. So we need to specify the task. So whether we want to classify, cluster, or predict. So for us, since we have a classification problem that we want to classify, we want to see if there is going to be a blood pressure or actually a coronary heart disease or not. So that's a classification again. So for classification, we can use a decision tree, we can use logistic regression, but if we have continuous or numeric target variable, then linear regression. And also decision tree can help, and neural network as well. So we will do some. Alright, so do that, and now I will go to the model, and then I will drag decision tree, I will drag logistic regression, and let's say neural network. Where is it? Alright, so I'll drag those for now, and then you can select the other ones that I show in the illustration here. And then I'll select those guys, I will connect them. Alright, so now I will go ahead and test and score. So I'll go to evaluate and test and score, and I want to see which one of those machine learning algorithms perform best. So I will make sure also when you are running this one to connect your file to the test and score. Alright, so now double click on this guy, and then we can see that we have multiple performance measures. So for simplicity, we are going to look at the classification accuracy. Most people actually use the AUC as a performance measure for the model, but for us, let's use classification accuracy here. So in this case, as you can see, this neural network performs best or better in comparison to decision tree and logistic regression based on the classification accuracy. Alright, so now that's the next step. Again, I have an explanation here. And normally other tools, they show you or ask you, or they do that automatically for you. They divide your data set into 3 categories: into a training data set, and a partition, and into validation partition and test partition. So in here for Orange, they automatically do that for you. So they divide your data set into 10 folds or 10 partitions. And actually one of them will be for test, and one for test, and 9 for training. So I explained that here for you here. So now we will continue and look. Now we can actually deploy our model. So I will stop here, and then we will do number 7 here really quick.